Okay, guys. I'm sorry. Today is the 16th. Recorded this on the 15th. It's Friday the 16th. This is the second day of logarithms. I'm going to start off talking to you a little bit about the change of base formula. If you have a base a logarithm of x, you can take the common log of the big number and divide by the common log of the little number, the base. Or you could use natural logs. You can actually use any log as long as you have the same base. But if you're using your calculator, you could use the common log or the natural log, and this formula will work. So this is used whenever you're given something like this, a base 3 logarithm of 7, and you can't figure it out using the one-to-one property or anything like that, then you can take your calculator and you can take the log of 7 divided by the log of 3 and get your answer there. So it's approximately 1.771. So that's how the change of base formula works. Now there's 3 properties of logs that we need to go over. The first one is the product property. You probably remember this from last year. Whenever you take the logarithm of a product, you can take log of the first factor and add it to the log of the second factor. So it looks something like that. They work hand in hand with the properties of exponents because the logarithm is an exponent. So they're pretty similar in that regard. If you take the logarithm of a quotient, so base a logarithm of u over v, base a logarithm of u minus base a logarithm of v. And then right here, log base a u to the v, that v can just come to the front like that and becomes a coefficient out front. So let me show you some examples how we're going to use this. If I have the natural log of e to the 6th minus the natural log of e squared. So I have a common base there. They both have a base of e. And I'm subtracting, so we can put that together and write it as one single logarithm. So we can say the natural log of e to the 6th divided by e squared, which would be the natural log of e to the 4th. And here we are again. We've got the base is e, the base of this exponent is e. So you can look back at yesterday's notes if you need to, but that equals 4. Okay. Let's look at another example. Let's we'll kind of work that backwards. Let's write the natural log of 2 over 27 in terms of natural log 2 and natural log 27. That last example, the term that's used a lot is condensing. You can condense these 2 logarithms and write them as a single logarithm to get your answer. This one right here is usually known as expanding. So you might see that from time to time. It may say expand the logarithm and write it as multiple logs or something like that. But this one right here I can take, because we're working with this right here, the natural log of 2 minus the natural log of 27. And then we can actually keep going here. We could do something like this. We could rewrite that 27 as 3 cubed. I'm going to take this one more and say the natural log of 2 minus 3 natural log of 3. So that would be completely expanded. Let me show you a couple more. Let's expand the natural log of the square root of 3x minus 5 over 7. So we're looking at, actually let's bring it down here, the natural log of the square root of 3x minus 5 minus the natural log of 7. Then we can rewrite that as 3x minus 5 to the 1/2 because it's a square root. So my final answer, I would use the power property is what that's called. Bring the 1/2 to the front. And there's your final answer. It's as expanded as you can get. Alright, let's see here. One more for you. Well, maybe the last one. Let's condense one-third times base 2 logarithm x plus 3 base 2 logarithm of x plus 1. Now, different ways we can do this, but I'm going to start working inside the brackets here, and I'm going to condense that part. So that 1/3 will just stay out there for now. And I'm going to say I've got a base 2 logarithm. That 3 goes up here, so I'm looking at x times x plus 1 cubed. And then because this is 1/3, then we can say that this is all a cubed root of all this. So we would end up with base 2 logarithm. That 1/3 needs to go to the x, and then the 1/3 goes to that, which becomes x plus 1. So that's the cubed root canceling out the cubic, and that would be your final answer. The condensing part, oh my gosh, I just did all that. I'm sorry. Here you go. Let me go over that again. The 3 comes up here and makes this a cubic, but the cubic only applies to the x plus 1, and then that plus says that we're going to multiply these two. So you end up with x times x plus 1 cubed. And then here's the 1/3 I was talking about. So the 1/3 will come and become the exponent of the x, and then it also comes up here. So the 1/3 is your cubed root, which cancels out that cubic, or 3 times 1/3 is 1, and that's your final answer. Okay, the last thing that I want to do is I want to find the domain of the logarithm. Y equals the natural log of x squared minus 1. Now, if you remember back last 6 weeks, we talked about special rules as far as the domain goes of a logarithm. What you need to remember is that this right here must be positive. Okay, so we're going to use our little sign chart. X squared minus 1 is x plus 1, x minus 1. And remember, you put your little zeros, those are your key points. -1 and +1. So remember, I can choose any number less than -1, any number between -1 and 1, and any number greater than 1. So I'll just use 2. When I plug in a negative 3 here, I get a negative 2 times negative 4, which is negative 8, which is positive. So that means I have graph there. When I plug in a 0, I get a negative. When I plug in a positive 2, I get a positive. So what that tells us is that the domain of this function is negative infinity to negative 1, right up to this point. It's not going to touch negative 1 because negative 1 would give you 0, and a logarithm, you can't take the log of 0. So we're going to make that non-inclusive there, and then we will go from 1 to positive infinity. Okay, so you've got a break in the graph between negative 1 and 1 because of that little area where you got the negative. So there's your answer. Feel free to choose some more problems in the book where you can practice that a little bit. It just remind you how to use a sign chart to find the domain. Thanks.